Professor. My name is Yuvraj. I'm the project manager for our Group 7. The name of our group is Agora, and today we are excited to present our interactive Twine project called the Heartbeat Decisions. The game is based on the ACM case study Medical Implant Risk Analysis, which explores the ethical challenges around the wireless vulnerabilities in the heart implants. We wanted to take this case study and transform it into a fully interactive, branching experience where players face real ethical dilemmas and see how their choices affect the patient safety, company reputation, and the public good. To begin, I would like to introduce our team and the roles each player played in the developing of this project. So for our project, each member took a specific role based on their strengths. I worked on the main coding and the story structure, whereas Karamveer helped media integration such as UI polish, heartbeat audio, and the visual enhancements. On the other hand, Rahul managed our GitHub repository and ensured that the code was reviewed and consistent. Rohit supported the coding process by helping with branch logic, gameplay testing, and debugging. And Chris designed the overall visual layout and completed most of the written report and diagrams. Together, these roles helped us build a complete functional and polished Twine game. For the presentation, each of us is also responsible for different sections. As I will be speaking first, so I will be covering slides 1 to 3, including our introduction and project scope. Then Karamveer will present slides 4 to 6 on the case study, gameplay, and the ethical dilemmas. Rohit will continue with slides 7 and 8, explaining the engineer and the researcher parts, which are the two starting parts of our game. After that, Krish will present slides 9 and 10 on the flowchart and the learning outcomes. Finally, Rahul will close the presentation with slides 11 to 13 covering peer feedback, future improvements, and our conclusion. Now that you know who we are, I would explain the overall scope of this project. So our main goal was to make an interactive ethical story where each choice leads to a real consequence. We used Twine for the first time, but we found that it is good for creating branching stories and letting players explore different paths. In our story, players make different decisions that might have a dangerous wireless problem. This helped us thinking about the real ethical issues like being honest in technology, being clear with patients, and handling pressure from the companies while still protecting the people. We wanted players to feel the seriousness of making decisions in a high stake technology situation. So, to explain why we selected this specific ACM, now I will pass it to Karamveer to carry it forward.
Thank you, Yuvraj. My name is Karm. I'm going to be talking about the next slides. So we have selected ACM case study medical implant risk analysis because it deals with the life-critical technology, a wireless heart implant. The case explains how a flaw in the device's communication protocol could allow unauthorized resets, putting patient lives at risk. What makes this case important is that it highlights conflicts between business reputation, ethical engineering, and responsible vulnerabilities reporting. Companies may want to hide flaws to avoid bad publicity, but doing so can harm real people who depend on these devices. This tension is exactly what makes this case ideal for an interactive ethical experience. Now I will walk you through how this gameplay works in our Twine game. In our game, players choose between two main roles: the engineer who discovers the flaw internally and the researcher who finds it from the outside. Each role experiences different pressures. The engineer faces corporate resistance, while the researcher struggles with the decisions about the public disclosure. We added heartbeat audio, animated backgrounds, flashing warnings, and images to make the story immersive and emotionally realistic. There are over 20 possible endings, ranging from ethical success to damaging outcomes. Depending on how players respond to the dilemmas, this structure encourages players to replay the game and explore different ethical perspectives. These choices naturally connect to several ethical conflicts, which I will discuss in the next slide. Our game presents dilemmas such as whether to report a vulnerability immediately, delay action to avoid pressure, quietly fix an issue without informing patients, or whistleblow to the regulators. These choices reflect the real-world challenges that professionals face when safety and corporate interests collide. Every dilemma is connected to ACM principles like avoiding harm, being honest, respecting confidentiality, and upholding the public good. By placing the player directly in these situations, we give them a safe environment to explore the consequences of actions that would matter greatly in the real world. And now I will hand it over to Rohit to explain the two main paths of the game.
Now moving over to slide 7. The engineer path follows Arnav, a lead engineer who discovers the vulnerability inside the company. He must decide whether to immediately investigate the risk, delay action, obey his manager blindly, or quietly fix new devices without telling patients. Each of these decisions lead to unique endings, such as becoming an industry leader, facing suspension, resigning due to guilt, or even becoming a whistleblower who protects the public. We designed this path to show how internal pressure and fear of consequences can prevent engineers from making ethical decisions. Now, now moving over to slide number 8. In the researcher's path, players take role of Dr. Lana, who discovers a flaw independently. She must choose whether to privately report the issue, reveal it publicly at a conference, sell the exploit for money, or pressure the company through regulators. This path explores the ethical challenges of disclosure, whether sharing information publicly protects or endangers the public. Her decision can lead to responsible disclosures, chaos caused by premature public release, earning respect as an ethical researcher, or losing credibility by publishing exploit code. It's a realistic look at the power and responsibility researchers hold when dealing with dangerous vulnerabilities.
I'm going to talk about the flowchart of our game. So this flowchart basically represents the full branching structure of our game. So we have built it to visualize how each choice is going to open or close different pathways. Players can take many different routes through which even early decisions can drastically affect late game outcomes. The complexity of this structure reflects the complexity of real ethical situations where small choices can lead to major consequences. So now let's take a look at what players can learn from this experience. So the main learning outcomes are centered around ethical thinking and professional responsibility. So players are going to learn that ethical decisions in computing are not very simple and often involve conflicting interests. They can see how delaying action or hiding any information or ignoring risks can lead to real harm. At the same time, they're going to learn that transparency, honesty, and responsibility are going to help build trust and protect the public. Our goal was to make ethics feel real, not theoretical. So now I'm going to pass it to Rahul to explain how feedback improved our final game.
Thanks, Krish. Uh, Peer feedback played a major role in our improvement, our final game. Our classmates said the original choices were challenging enough, and we expanded the dependency, the story significantly. They also said narrative lacked emotional depth, so we rewrote the scenes and make them more realistic and meaningful. We also added more branching options, more endings, heartbeat audio, warning animations, images, and ACM summaries. Every ending, every piece of feedback was addressed, and the game became much stronger as a result. Next. Next, here's what we would have added if we continued this project. So, if we had more time, we would expand the game with features such as voice narration, character animation, and more immersive sounds. We would also add accessibility features such as text size controls and colorblind friendly modes. We would also consider adding a second chapter showing how hospitals, patients, and regulators respond to the vulnerabilities. These improvements would make the game even more realistic and educational. Now, I will finish with our closing remarks. In conclusion, the Heartbeat decision is an interactive way to explore how ethical decisions affect real people, especially when technology interacts directly with human life. We hope our game players realizes the importance of the honesty, transparency, public safety in computing professions. Thank you for listening. We hope you enjoyed a great experience for the game for yourself.